Okay, in this problem, we have a motorcycle that accelerated 3.5 meters per second squared while traveling at 90 kilometers an hour. So at 90 kilometers an hour, there's a lot of air resistance, and the problem tells us that air resistance and everything else in terms of frictional forces add up to 400 newtons. The question is, what is the magnitude of the force the motorcycle exerts backward on the ground in order to produce acceleration if the mass of the motorcycle with the rider is 245 kilograms? Well, think about what this is saying. There is a force backwards on the motorcycle of 400 newtons, right? And then the question is, what force must the motorcycle exert backwards? Well, the motorcycle exerts a force backwards on the ground. That means the ground exerts a force on the motorcycle, right? And so what we want is for the total net force. Remember Newton's law. Your net force is your mass times your acceleration. Well, in this case, the net external force, i.e., the force the ground exerts on the motorcycle, which is equal and opposite to the force the motorcycle exerts on the ground, right? If we draw the wheel here, the force the motorcycle exerts on the ground is equal and opposite to the force the ground exerts on the motorcycle. So the net external force, there's the 400 newtons of friction, and then there's the force the ground exerts on the motorcycle. These are in opposite directions. These are opposite directions. So what does that mean? Well, what we're looking for is for F net, right, equals to mass times acceleration. They gave us the mass, they gave us the acceleration. And we know that F net is equal to the force exerted on the motorcycle by the ground, minus 400 newtons, right? So we have to take out the frictional forces. Those have to be overcome. That gives us our net force. We stick all of this in. We have a little space in here. Force, I'm just going to put M for motorcycle, minus 400 newtons equals, and their mass was 245 kilograms, and our acceleration is 3.50 meters per second squared. All right? And so the force on the motorcycle exerted by the ground, or the force the motorcycle has to exert backwards, is then 400 newtons plus the 245 kilograms times 3.5. Let's get what that is real quick. All right, 245 kilograms, 3.50 meters per second. We just want their product. That's 858, right? 858 kilograms meter per second squared. Now, kilogram meter per second squared is just a newton, so this is 400 newtons plus 858 newtons equals 1,260 newtons if we're going to keep everything at three significant figures. 1,260 newtons. And that's the total force that the motorcycle has to exert. And that's it for problem 4.10.